Hello, Powermetrix Nation. So this is the third and final part on our 8S site. Already had some questions same day because we're filming it today because I'll be at Mid-South Meter School next week. So there was a question on the 8S versus the 9S. This is for classroom purposes, and technically, as we said before and I mentioned in the video, this goes back to the electromechanicals, where a 9S was just, it was only rated the 120 volt, whereas the 8S covered a lot of different voltages. So, so the thing was, this would, since it's a delta like this, it would be an 8S site technically. But I have folks that put it in as a 9S site and test it. They'll go to a 9S and go to a 4-wire delta and test the site. But technically, for classroom purposes, also for the paperwork and everything, this would be an 8S site. So that's why, and I had that question asked. Where we are right now is, we'll just go through the housekeeping stuff. This is number 12. So this is the final part. Next week we're going to pick which one we're going to go on the next one. If you have one that you would like to see, remember we have 3S, 4S, 5S, 6S, and 9S still left. Pad mount and overhead. So if there's anyone you would like to see, contact JP. And we'll maybe look at, maybe take a vote and see who asked for the one the most, and we'll go with that one. Otherwise, we'll just pick one. So for today, we're going to do a customer load test on the meter, then we're going to do a CT ratio and burden test on the CTs, and then we're going to show the multiple revenue points for one service type, so where they fed off of this 8S to another revenue service there, a revenue site, and we'll show that where it goes to another meter, so we'll talk about that as well. And we're going to go through a quick preview, of what we talked about before, and then we'll go right into the video. But before we do that, let me say a quick prayer, and then we'll get rolling, all right? Father, thank you so much for this time again to learn our craft. Thank you so much for all of this technology that's in place that we can reach out to people all across the country and around the world. We have a lot of international people actually tuning into this. It's pretty amazing in this situation with COVID and everything that we can do this, and we're so appreciative of that. And Father, we just want to we lift this country up, and Father, we're just so thankful for what we do have. It's when things aren't going that well, it seems like we, as people, it's just the way you wired us, Lord, that we tend to go in a negative direction. But I'm so thankful for what I have, these teammates that I get to work with, these professionals, and also the Powermetrix family. They know how I feel about them. It's just, it's really a joy to work with folks that actually, if you think about it, they carry on a sacrificial type of work ethic. They put themselves on the line for other folks every day out there, and then there's all the people that support those folks that are out there in the field. So, so thank you for letting me work with those type of people, Lord. And Father, I'd just like to thank you so much for your Son. Without what He did, we would have no repentance. We would have no the ability to pray. So, so His death on the cross allowed all that. So all of these things I ask and say according to the will of the one who paid it all, my brother, Jesus Christ. Amen. So let's do a quick, we're going to do a little review. So we're going to talk about some of the things that we said before, and then we'll go right into the test, okay, and the filming. So if you remember, one thing I thought I might point out real quick, when you looked at the vectors on this, you noticed that it was a little different. The vectors weren't the usual Y that you see. This was a delta setup. So let me see where I put my. Where did I put my? I got a green one. You got a green one? No, where's my black one, man? My black. Oh, here it is. Never mind. Oh, nice catch. Okay, so let's take a look at this. So here is. If you noticed what you saw before. I'm glad I caught my little glitch geometry yesterday. So you got, as far as the degrees, you got 0 here, you got 90 here, you got 180 here, you got 270 here, and then, of course, if it comes all the way back, it'd be 360, a complete circle. So with the one that I showed was what you see on a Y, which would be my red. Got my red at 0. I'm here at 120 with my yellow or my B, and then I come over here and 240 with my blue. Well, for a delta service, right, if you noticed, it looks more like this. Okay, so that's what a delta service looks like. And it's easy for you to remember that because if you think about it, if you just connect these, right, get a delta. So just a way to remember that when you see it. And remember on the equipment, there's a reference button, so you can hit the button if something looks squirrely on the vectors to you, and it gives you a reference of what it would look like. Now that's going to be, of course, you're going to have it so it's going to be the power factor is going to be 1. So everything's going to be lined up. The voltages and the currents are going to be lined up with one another. But anyway, it will show you the ideal of it, and you can look off of that. And of course, we don't have that in the field. You're going to have some loss, so there'll be a separation of the voltage and the current vectors. But still, it'll give you an idea of what it should look like. Okay. So if you remembered when you saw in the video, and you're going that our C phase, that high C leg was going straight up on us. Okay. And some of the little tips and things that we saw, I like the way, the way Brylan had his table set up. He had the kit was sitting on top of it. He had his cables laid over that lid right there before he got going, so he got them all separated, so he wasn't trying to do all that in the middle of a test. He had them laid out before he really started going. Then he set everything up on the equipment first, and then he made his connections. And that's another point we had talked about on some questions we had today. Remember, there's different service types on the equipment that you can pick. So when we went to the 8S, it did default to a 4-wire delta, but remember, it showed two voltages, 3 currents, or 3 voltages and 3 currents, and in this case, it was 3 and 3. So you looked up there and you had 3 pots up top. So and as we're going through these, you'll see that becomes important because sometimes you're running 2 services through 1 CT, and so you won't have true 3 volts, 3 currents, so it can change on you. So you'll see that in future episodes of this. But in this case, 3 voltages, 3 currents, so that was the selection that we made. The 8S, the 4-wire delta, 3 voltages and 3 currents is what we chose on there. And then just some other things on the connections. I hope you can see this. It's a little bit far away. But we talked about our voltage alligator clips. You've got that tooth, the teeth in the end of it. If you've got holes in the end of your tabs, and your switch seems to be in pretty good shape, you can grab on the end of it with that alligator clip, and it'll hold on there. You can feel it. It'll pull because I've got the 1 in the top and 2 on the bottom, and they tend to grab into that hole in that tab, and they hold on really well. Or you can actually take the alligator clip, and you can go on the blade, the voltage blade of the switch, right? And if you coin it a little bit, if you're in corrosive areas, it doesn't have to be. You don't have to be on the coast somewhere to have corrosion. Our guys have been out there testing where they're burning manure and for methane and stuff, and the switches are just black, or depending on a chemical plant, if you're near there. So it doesn't have to be where you don't have to be in salt air. You still have corrosion. So if it's a heavily corroded area, you might just get on that blade and you might just coin it back and forth and let those teeth rub on that metal and get through that corrosion and coin that surface so that you're getting a good metal to metal. And I don't know if you noticed this or not, but Brylan's done this so much that he even turns these alligator clips a certain way on those voltages. And the difference being, remember, if you can see this, you've got the short stroke of the shunt blade for the CTs, then the long return, right? So what he does is when he makes his connections there, if he comes over here and gets on this, if he turns it to the left, the handle, and gets on this blade, see, what can happen then is when you get ready, you put your voltages on first, and most people put voltages on first, then they put their duckbills in. When I open that long stroke return blade, it wants to pull my voltage off of there, my alligator clip, so he always turns his to the right, and then when he opens it up, he doesn't have to worry about that. And remember, it's a short stroke on the next phase. That's A phase, so when you get over here to B phase, it doesn't mess with it. See, so it's just these little things, but it can keep you from having, usually when stuff like this happens, when it's scalding hot, mosquitoes swarming around your head, and you're wanting to get this test done, and then you got the nuisance of knocking your voltage alligator clips off of there. So it's just little things like that that we want to point out because this is about training, right? So that can be a little pointer you can use in the field so if you're going to get on the blades just to coin them and make the connection that way, okay? Because unfortunately, these little bitty teeth on the end can get broken off. So it's up to you. You do it whichever way is more comfortable for you. But just always look and make sure you've got the teeth on there if you're going to go in the holes in the tabs, because otherwise it could give you some issues on picking up the voltage correctly. Okay? So and we also talked about the differences on these on the vectors of we've got if you have polarity reversal, you're about 180 degrees out on the same phase. If you're 120 out, where everything's shifted around 120, then that could be cross phasing you could see. And so those those vectors are so important to you. So make sure you look at those vectors really well when you're getting ready to start the testing, right? And then be sure and make your connections. And remember, we talk about this a lot, and the reason why we didn't show it here was, and I guess I could have since you had two-man crew here, if you're by yourself and you're using a high volt probe, you're not already connected to the primary. So we talk about a lot toggling and looking at that primary current versus secondary current on checking to see if maybe you have one of your primary CTs in there backwards. Well, when you're using a high volt probe by yourself, it's a little more difficult because you have to have it up there reading the primary current before you can take a look at that and see and toggle between primary and secondary current, okay? Taking a look at that on the vectors. Because remember, if it's the secondary always follows the primary, so if there was something incorrect, it would follow it, and if you just did a CT ratio test, it wouldn't show up for you. So toggling like that, if you have the wraps on there, your flex probes, then it's easy. I've got one on each of my three phases in a Y, so I'd have one on each of them. If I did that, then I'm looking at my primary current, so I can toggle on that primary current, okay? But if not, if you're just using a high volt, if you can get it up there somehow where it stays in place and you want to take a look at it, you can. Or if you're a two-man crew, then you can have one guy operating the machine, the other guy's operating the high volt probe, then you can get it up there and say, hold on a second, you can take a look at it, okay, and toggle between them. But the other is, as you go to the next phase, okay, you would have to start, if you wanted to do that with a high volt probe, before you started the test, you'd have to look at all three phases, right? So you'd have to get on all three phases with that high volt probe. That's up to you if you want to do that. It is a lot simpler with the flexes because you already have them on all three phases, so you can just toggle it, okay, and take a look at them, okay, and it shows you all three phases. Okay, so what we're going to do today is we're going to show the video, and of course I'm going to stop at certain points and want to talk about it. But right now, what we have seen is we've seen it's telling us so far it's an 8S. And it is it's a 4-wire delta, three voltages, 3 currents, right? And so we've got vectors that look like this over here. So far, we haven't seen anything that really, made us stop and say, whoa, we don't need to move forward. So far, everything looks okay. We did an inspection of the pole. Everything looked okay on that. We didn't see anything that really worried us. We didn't see any separation at the bottom. We didn't see any open we didn't see a lot of stuff that made us, really worried about stuff. So in this case, we're moving forward with the test now. So Brylan's going to go ahead. He's going to operate the stick, and I'm going to press the buttons on the machine, and we're going to go ahead and move forward with the test. If we stop right there. Oops. So here is where, when we were setting the test up, this was an integrated site test. So you notice the choice that Brylan made was number 2, which is an integrated site test. And that is where you can set it up to do one test after another. And when you do that, you don't have to jump between menus and change anything up. And you don't have to go and select a meter test, then go choose an instrument transformer test or a CT or PT test. No, it goes from one to the next. And the equipment shows up, this equipment shows up standard with a customer load test on the meter and then a CT ratio and burden test on the CTs. You can do other tests if you like, okay? There's going to be in a minute here, I'll stop it. If you noticed if you didn't have much load at all or very close to no load, you're going to want to run a phantom load test on the meter, and then you'll need to do a load boost test on the CTs. Now, why is that? Because if I don't have enough of a customer load test, especially with the CTs, it's really tough to test them because CTs, we don't like them when there's not much load on them. That's the old bathtub curve, remember, and if you get below 10% on there, according to ANSI, it's not a good test. And that is where, and I'll just draw it real quick. I'm sure you've seen this tons of times, but it's the bathtub curve here. So forever, now remember we've got extended ranges, higher accuracy CTs, but before that forever the standard was you were at 10% of the loading of the CT and then 100%. So for a 400 to 5 CT, this would be 40 amps and that would be 400 amps, right? So when it gets below 40 amps on that CT, that 400 to 5, my accuracy starts getting bad quickly, okay? It goes in a bad direction. And then if I start overloading them, this is before extended ranges and everything, I'm just saying it also gets bad, okay? So what I don't want to be is on the, I don't like to underload CTs, that's just a general rule of thumb, before the more advanced CTs, like I said. But you don't want to underload them. So if you had a case like that, remember you're going to look and see how much is on there, and then you would change the test. But for a customer load test, and then the CT test, you're counting on having enough loading there. And we're going to talk about that here in a minute, is the number that we look for, okay? And I'll stop at that point and talk to you about it. But looking at this screen right here, you can see what's checked on here. It shows you before you run the test what's about to happen. And what's about to happen is I'm going to run a customer load test on the meter, and then I'm going to run, you can see the check box here, I'm going to run a CT test, I'm going to do a burden and ratio test on here. Remember, we've talked about this a lot, double wrapping. If you double wrap your CTs, you got to check the double wrap box, or it's going to say that your 200 to 5s are really 400 to 5s. You also can change how much burden you put on there. For this piece of equipment, it shows up, it's going to put a half an ohm on there. This one can go all the way up to 2 ohms. It can go 0.1, 0.3, 0.51, and 2 ohms. And 5 steps up to 2 ohms, this piece of equipment does. And here's another thing over here, and we're going to talk about in a second. I can also change the length of time on the test. I can go by time, or I can do by the number of revs or pulses. So I can go, if I set this up as, let's say, 30 seconds or 3 revs, then it's going to be whichever the machine sees first, it will complete the test. So if you had enough load on there, and it ran through 3 pulses before the 30 seconds, it would complete the test. If you didn't have enough load on there, and it ran through 30 seconds and only had, let's say, 2 pulses, it would still complete the test, but it would only have 2 revs or pulses on there. So it's whichever it sees first, but it has to have at least 1 good pulse. So if the load was really light and you went through 30 seconds and still hadn't seen one, when it finally got 1 pulse, it would complete the test if you had set it up as 30 seconds or 3 revs. If you leave either of these 0, it will complete the one you have filled in. So in this case, if I leave it just like this, it's going to go to 3 revs no matter what before it completes the test. If I put the revs as 0 and made this, let's say, 120 seconds, it's going to go through 120 seconds before it completes the test because you have this as 0. Okay? So let's go ahead, JP. I didn't look to see how much did it have on secondary.
2 amps on secondary, all 3 phases.
All 3 phases had 2 amps on there. So if they've got 2 amps, that falls within, remember Brylan saying a half amp, less than a half amp, you start kind of looking. But we're well over that, so we should be fine. So we should get us a good pulse here when we get one. Just now start test pops up once that lights up, right? So then Brylan just hit start test, and we're going to start into it. This one should run pretty well with 2 amps of secondary on it, so it should run pretty quick. Okay, you can stop there, JP. Okay, so what it's doing is, and we've talked about this before, but now you're actually seeing it out in the field, we have pulses expected and pulses actual. So the actual is what the pickup, and there was a magnetic pickup we put on that hog nose or that COM port there on the face of the meter where the pulses are being emitted from, and it is counting the pulses, and it will count them 1, 2, 3. Remember in this case, 0 or 3 revs, so it's going to count 3 before it completes the test. What the pulses expected is, so we come over here, pulses expected are for a transformer rated meter, you'll put in there and you'll say 1.8 is the K sub T, right? My K sub T for testing. So if my K sub T is 1.8, that means when it sees 1.8 watts, it pulses. Okay? So what happens is it's counting the pulses. So I counted 1 pulse. So now I'm going to check and see, is that 1.8 watts? So you see this equation all the time. We talk about it a lot. It's current times voltage times power factor equals watts. So we're measuring the current with the duckbills, we're measuring the voltage with those alligator clips, right? And we're counting the pulses with the pickup on the front of that meter, on that COM port. So what it does, it says, I counted 1, so now let me take that and I'm going to measure those number of watts. I'm going to divide by the 1.8 and see how many pulses that should be expected off of what I measured. So we come over here, and when we have measured it, the pulses expected says 1.007 here after 1 pulse. But remember, he chose 3 or 0, so it's going to complete 3 pulses before it finishes the test. Thanks, JP. And like always, as it goes through each of the pulses, it'll say test in progress, and then when it finishes, it'll say test complete. Test in progress in red, testing complete will be in black, and as it goes through and hits each pulse, it'll give you the tone, and then you can see it went test complete in black. Stop there.
And it finished out 3 pulses because Brylan left is 0.
Okay, so notice it says test complete right here, okay? And if it didn't like the number up here, it would tell you down there at the bottom that it'll give it in red, you know, in the case for this piece of equipment, and it would let you know you might want to check your connections and check what happened because it's outside of the parameters. And that's another question I get asked. I was asked it just a little while ago. You set that number on what is a pass or fail, okay? Every utility is different. The electronic meters are 0.2% accurate, okay? So that means they're looking for, if you're looking for a range of pass or fail, then you're going off 100 as being the baseline, and it's 0.2% above, 0.2% below. So you're looking at 99.8, which is 0.2 below 100, to 100.2, which is 0.2 above 100. Anything in there constitutes a pass. Anything outside of that is a fail. Okay, just got a call from someone that said, I've got 100.6, and it's telling me, it's giving me that red message at the bottom, it's not liking it. Why is that? And I told him, I said, well, the piece of equipment you're using shows up from the factory set at default at 0.2. So that means it goes 100.2 to 99.8 is a pass. He was at 100.6, so he was too high off of that range. But the this equipment can be set for whatever range you set it for. So you can go in and adjust that, and according to whatever your utility wants to use, it can be 2%. It could be 98 to 102 is a pass. Anywhere in there is okay. So if you got 102.4, that would be a fail because it's higher than the 102. So in this case, it fell within the parameters, whatever it was set up on the machine at the time. So it gives me test complete in black. Everything's fine, and I can go on to the next test. In this case, that's awful darn good, okay? Remember, if it's below 100%, the utility is losing money. If it's over 100%, the utility is making a little extra money. In this case, a very, very little extra money. That's a tiny bit. So you would consider that a darn good test. Thanks.
If you leave 0 on the time and you have 3 over on the number of pulses, then it's going to go through 3 pulses or revs before it completes the test. If Brylan had put any kind of time in there and revs, it's whichever it sees first, okay? So you can set it up that way. Sometimes I've set it up 30 seconds and 3 revs. I like that one because if I'm out there and there's hardly any, you know, I got hardly any load on it, and and I'm going to sit there and wait forever for a pulse, I don't have to sit there and wait forever. It's whichever it sees first, but it has to get 1 good complete pulse, okay? So let's say it had a really light load, it got 1 pulse inside the 30 seconds, and I had 30 seconds or 3 revs, then it would go ahead and complete the test and give you 1 pulse and say it had completed it. But when he looked and saw the 2 amps on its secondary, he knew he was going to have enough that he didn't need to go ahead and make that 30 seconds or 3 revs. He just left the 3 revs on there because he knew he'd run 3 of them through there on 30 seconds, which it did. It ran through them fairly quick. So it looks like we got 100.002. That's awful darn good. The utility company's making just a tiny, tiny, tiny bit off of them, but it ain't even enough to worry about. That'd be a great test. So we completed that test. So then we always hit that our favorite button, F6, and go to the next test in our integrated site test.
So this is when you do the integrated site test, all you have to do is hit the button saying next test here, and it's going to go to the next one. Remember, we're set up to, off of the setup page, we're going to do a customer load on the test, meter, which we just did. Now we're going to test the CTs. This color diagram, what it shows you is where you're supposed to make the connections, okay? It's not interactive, but it does show you for the service and service type that you have up here, where to make your connections. So in this case, you can see here it is showing whatever kind of probes you're going to use, whether they're flexes or the high volt probe, you'll go individually on A phase, B phase, or C phase. If it had wanted to do a figure 8, what it would show up there at the top would be A, B, C. So what you do is, if it showed this, if it showed a figure 8 on there, then it would tell you that you need to perform a figure 8 with that flex probe, okay? That's where you're going to put it in 2 different directions. So remember, there are arrows on both the high volt probe, and there are also arrows on the flex probes. And you're supposed to put that arrow in the direction of the current or towards the load, okay? So if you do that, if you think about it, if you figure 8 it, and I've got one right here, go off camera for a second. Really? So if you figure 8 it, if I figure 8 this now, I've got the arrow going one direction through the top and the opposite direction at the bottom here. So what I might do that for is if I'm using B as a reference, if you think about it, if I figure 8 the bottom here, and then I figure 8 the top up here, what happens? I'm measuring B phase in 2 different directions. That direction, the arrow going that way, and the arrow going the opposite direction, it will cancel out B phase. I'm just using it as a reference, and I'm just looking at A and C phases, okay? Reason I would do that is if I'm running more than one conductor through the same CT. But in this case, it's showing you I'm going A, B, C. So I'm going to individually use my high volt probe and get on A, then move it to B, then move it to C. Or if I had 3 flexes, I would wrap flex A, then flex B, then flex C. There's no figure 8ing or anything like that I need to do here, okay? Now, one thing that I'm going to point out here, I did it in the field as well. It always shows this color diagram before the meter test, and it always shows this color diagram before the CT test. And on the CT test, it's looking at the primary current. And you can look right here, I've got 3 red dots on my primaries, and it's saying right here, missing probe, please check and rescan. So Brylan, and you'll see it here in a second, had not connected the high volt probe yet up there. It detected that and said, wait a minute, you've got to connect that. So it does look for the connection to the primary probe and make sure you've got it connected before you can move forward with the test. It's going to let you know right here that you don't have anything connected right now, all right? Okay. Because remember, it goes one after the other, and in this case, it's going to do a custom load test on the meter, and then it's going to do a ratio test on the CTs. So, and it's showing our connections here again, and it's saying here that we need to be on A, B, and C phases separately. You can see right there, separate on each of them. There's no kind of figure 8s or anything shown on here, so it looks like it's going to be all separate. So we're going to do each one separate right there. And right now, it's interesting, he doesn't have any of nothing's connected up right now. So when he doesn't have anything connected, that's another good thing to teach here real quick. Notice it left those in red down there because it's saying, missing probes. Please check and rescan. So now that he's connected up his high volt probe onto the probe adapter cable on here, whatever's got it connected to your probe that you're using, usually the test kits will tell you and say, no, I'm not liking that right now because nothing's connected to it. And it did here. So it said, hey, it says you need to connect up your probes, and since we're using the one, remember, it's going to give us the solid green on A and an open green circle on B and C, and it's going to let us know we need to move it to B and C. So I'm going to go ahead and rescan them real quick. JP will come here and check this real quick, and I'm going to, when he's done there, and I'm going to go ahead and rescan now that he's connected. I'm going to hit rescan probes, and see now it goes to what we wanted to see, which is solid green on A, open green circle on B and C. Before that, it was all red circles telling us you don't have any probe connected yet, okay?
And remember, if it was 3 flexes, if we connected 3 flexes on here, it would be 3 solid green dots on primary A, PIA, PIB, and PIC. On primary A, primary B, and primary C current on the color diagram. Ready to roll? All right, let's go ahead and hit it. So we're going to hit next. So like always, when we're using just one probe, whether it's a flex or a high volt probe, it's going to tell you to move it to phase A and then hit F6, our popular button there, F6. That's what we're going to do.
Stop it right
So we got to pass.
So what we have here is you can see the CTs that are stacked up here, right? You've got 3 CTs that are stacked up right here, 3 voltages, 3 currents. So we've got 3 CTs up there. One thing that I wanted to mention, you can't see it real good here, but you'll be able to see it here in a second, hopefully, when he's moving his stick around. With that fiber optic cable, and then all these high volt probes have a base unit, and then they have a head unit, or the horseshoe at the top. There's a fiber optic cable that connects the 2 of them for communication. If you notice here, what Brylan is he's got a Velcro strap that he strapped on that fiber optic cable up at the top near the head unit up there. Or sometimes they'll have a little loop strap that you can maybe loop it on something. So you want to have strain relief off of that fiber optic cable. You have to be careful. I wish that we could get these things that were wireless, but we can't. You know, we've talked to the manufacturer and they just keep telling us that they can't do that. That would be ideal, because then we wouldn't have to worry about that fiber optic. But for now, we do. So for anyone that uses these type things, you're going to have to use that little, you can see that orange fiber optic cable going up there. The problem with that is it's not very durable, so you can break it easily. You can break it at the connection, and so what you want to do is you want to have some strain relief on it. And be careful when you're going up in there too, because you can also, if you grab it onto something and jerk or pull on it, you can also break it, okay? I hate to see them when they come in and they've got a fiber optic issue, because there's not much you can do about that. You just have to get them a new fiber optic cable. So be careful and cognizant of the fact that those fiber optic cables are not very durable. They can get broken easily, so be careful with them when you're taking them down, you know, and you're wrapping them up and everything. Put them in a good spot. Don't leave them kinked up and everything with something heavy on them. Just be careful with them and get you some strain relief at the top. I would recommend, if you've got the little loop, some of the the high volt probes on the head unit, you've got a little bitty, looks like a little harness where you got to thread it through and all that. I don't do all that. I'll just take that little loop and I'll just loop it over my wire nut, my wing nut. Okay, so when I'll put it around my wing nut, it's just easier to get on and off, but it still gives me that strain relief. Okay, and you'll notice he angled that high volt probe so he could get in there easier, because he's wanting to just get around these 2 conductors you can see here that are going into that CT. So by angling it, it's a heck of a lot easier than if he had it straight up, right, and was trying to get in there. You would have to create a heck of an angle by getting way far away on there and create an angle. Working these high volt probes is an art, okay? Getting up into crowded pole tops. So what you want to do is, when he angled it, it allowed him to just slide that thing in there and just get on just those 2 conductors right there. Like I said, if he had it straight up, right, he would have to get way over here to try and get enough of an angle so he's not grabbing more than he should. Because that's the main thing with these probes, both with a flex and a pad mount or this overhead. You just want the conductors for that phase inside the probe, whether it is a flex or whether it's the high volt probe. Okay? Thanks.
So we got to pass. And according to this, it's telling us those are 405s. That look right to you, Brown?
Best I can tell, yeah.
Okay. So it's telling us that they're 405s up there, because the way that it runs the test is it comes up with a ratio, and then it says if it's 396 to 5, then the nameplate ratio is going to be 400 to 5. And the way the machine works is it looks within a percentage off of that and says, well, that must be the size of the nameplate ratio. So it's got a span there of around 400, that if it falls within that, it says, okay, it must be a 400 to 5. In this case, at 396 to 5, it said, yeah, it must be a 400 to 5. So we didn't have to enter in the size of the CT, right? Brylan didn't enter that in there, right? He just entered the top half of that information, like we always talk about on that test screen, or I'm sorry, on the site setup. So when we did that, we just set that up as, hey, here's all the information you need up here, and we're ready to start testing, but he never entered in the size of the CTs. This calculated and came up with 396 to 5, and then it said, okay, if it's 396 to 5, then the nameplate must be a 400 to 5, okay? So we're getting a pass on that one. Our angle's fine. Our ratio's really low, it's less than 1%, so that looks good. And we didn't have any phased angle error that caused us any problems there. Sometimes you can get a pass. If you look at the numbers, the ratio looks good, but what happens is if you look at the phase angle error, you got a problem there, okay? And that's, for us guys out there trying to get stuff tested, that's a pain in the rump, it's a nuisance. So that's when you either need to maybe reposition your flexes or reposition the high volt up there up top, okay? You may need to just move it a little bit. Something's interfering and causing a problem. So you might get a little bit closer to the CT or even get away from it so you can get away from some of the other stuff up there. Because remember, that horseshoe up there, there's no insulation on the outside of it, so it can pick up and get interference from other stuff. So, and they are positional, so you might need to just move it a little bit, okay? In this case, both the ratio and the phase angle error came out fine, so it gave us a pass on it. So now, moved it to phase B, rock and roll. We got a pass on that one. This one's real tight. It came out 400.58. That's pretty darn tight. So you can see how low our ratio error is. Very, very low. It looks really, really good. Didn't get any problems on phase angle error. So phase B looks good as well. Now we'll get over on that high C leg. Good? Working awful fast, son. Give me a chance. I'm pressing buttons over here. All right. So now we're going to go to C and we're going to hit it. We got to pass on it. 397.22. So we also, that's enough.
So when you heard the clicking sound in the background as we're performing this test, what it's doing there is it's doing the burden test on there, because what you're doing is you're throwing in these resistors, because remember, burden is just resistance. It's measured in ohms. So as you hear that clicking sound as it's performing the test on each phase, when we start the test, when we hit F6 and we start the test, it's throwing in, because it's, in this case, it was set at 0.5, so it's going to go 0.1, 0.3, then 0.5. It's going to keep adding resistance to it, and it's looking for a drop-off of the secondary current, which means it's right there on the edge of failure. And we've talked about this in the other webinars. What you're looking for is you really wouldn't want that to happen on one of those early numbers that you're throwing in there, like 0.1 or 0.3. Okay, if you saw that secondary current drop off, that means for whatever reason, loose connections, damage to the CT, whatever it is, it's just sitting there right on the edge of failure, because that is indicative of a failure. When I get that secondary current has a steep drop off like that, that means that that is when that CT fails. Okay. Another thing I'd like to point out here. Notice we used the number, and I jokingly called it the Brylan number. We're out there in the field. But what we're looking for, if you get ready to test these CTs, you want to have at least a half an ohm of secondary current on there. In this case, 3.2, 3.6, 2.598, almost 2.6 there. Those are good numbers. If you get up there too, when you see a failure and you're running and you're testing those CTs and you're looking at them, look at that Rolodex, right? One of the things to look for is how much secondary current I've got. And then the reason why he uses 0.5, and I like that, is anything less than 0.5. If it's 0.4 and it's high and it's almost 5, then you can feel good about it. But think about what that number is. If it's 0.5 secondary amps, it's 20 primary amps, right, on a 200 to 5. If I take 1/10 on the one side, we'll come over and look at it real quick. Stretch our math minds here a little bit. So we're going to go. So if you got a 200 to 5, right? If this becomes 0.5 on this, 1/10 on this side, 1/10 of, right? 1/10 of 200 is 20. So that's at my ANSI level. That's where we're saying we need to have 10% of the primary current is what it's asking for, right? So test a lot of 200 to 5. So over time, he's just got in his head, if he sees less than a half an amp, that's where you might get a failure. and on equipment, on this equipment here, it would give you a failure on the ratio and a failure on the error on the ratio. A failure on the ratio and a failure on the phase error as well. If you see those failures like that, one of the first things you do is come over here and look at this. Or before you start the test, remember when we're looking at the vectors, a minute ago we looked at the vectors, you can see it on there as well. Because if you don't see any load on here, you know either you can't test that site if you don't have it, or if you have a load boost kit, you're going to need to boost it and get it up higher, and you're going to put at least 20 amps on a 200 to 5, so you're at that 0.5 number, because when I'm at 10% of the rating of the CT, that's considered a good ANSI test. So if I'm down there in a low number, I mean, every once in a while you'll get lucky, and you'll test one at 0.3 or 0.2. That's just, you're just lucky that day. But be consistent and have general practices and get it in your head. If you start getting below 0.5, you're going to have a tough time testing them, and you'll tend to get failures, and it'll give you a failure on the ratio and a failure on the phase angle error, okay? In this case, these are all good numbers, and it reflected in getting good tests out of here, okay? So remember, if you see failures on this, one of the things to check is look at how much load you've got on there and how much current you've got on those CTs, okay? Another nice one, it's very, very low ratio error on that one. Way less than 1%. Our angles also look good, so we got a pass, and a pass on all three of them. And it's showing up, all of them as being 405s. Oops, no, never mind. I was going to show where he had that wrapped around the strain relief on that pole. That's good. So everything came out fine on them. So as far as we know on this side, everything looks good. We got a really good meter test, got a really good CT test on it. Both of them are really, really tight. We would say there may be some things to let the guys know about as far as the condition inside this can and stuff. They might want to just check it out, do a little cleaning there next time they're here. But isn't it amazing? It just goes to show you sometimes the stuff can look pretty bad when you open it up, but the measurements, everything come out pretty good. So they're not losing much at all at this site right here. I mean, 100.000 on the registration of the meter, and then as tight as those CTs were, I'd say this one's the revenue that's coming in on this one's right on time with what they're actually seeing at the site. So I think everything's reading really well here, so I think this would be a site that you would say is metered very, very well, and they've done a really good job as far as the connections. It doesn't seem like there's anything really loose on this side with the CTs and everything, otherwise those numbers wouldn't be so tight. So this is you'd say this is a really good site. You could check this one off the list and think you're not losing much money and go on to the next one. So while we were here at the site, we wanted to point out one other thing, which is another good learning tool. I mean, while we were here, this you can see what they've done here at this customer. We've tapped off a single phase coming off of that. Remember, we had the 8S. It was that 4-wire Delta High C leg service, and we tapped off of a single leg of it and used a 2S residential meter here for a smaller service here. Well, one thing to point out would be the reason that they use the 2S, well, obviously the cost, a residential meter like this is going to cost less, but you got the difference between if you're tapping off of a Y service, you would need to use a 12S meter, because if you tried to use a 2S meter, remember that a 2S meter is looking for 180 degrees out on its two phases, right? So it's trying to pick up phase to phase there and get 240 volt. So it's trying to look 240 volt at 180 degrees, whereas you got 120 degrees between your Ys, okay, on your vectors. So what that does is it roughly throws it off about a third. So if you tried to use a 2S meter coming off of a Y service, then you would be off. You'd probably be about 33% low on it, okay? So this is just another thing to point out, that the difference in the meters sometimes not only is just the cost, which obviously you want to try and be cost effective out there, but also if it matches with the service. So in this case, you would want to use a 2S here because we're tapping off of this Delta service. If it was a Y service, then you could use a 12, and you would need to use a 12, okay? So this is just a difference there. Just another little learning tool while we were here to show, and JP got a good shot of it feeding off of that service we showed him coming into this meter, okay? So they like I said when we were saying what the agenda was for today, they had 2 revenue points there at this one service. Now, remember, if the position of your flexes and the position of the high volt probe are always important. Get some strain relief on that fiber optic cable. He used a Velcro strip, or you can use, sometimes they'll have a little loop on the fiber optic cable that you can grab on. I recommend getting on that wing nut. But angle and get in there at a good angle so you're just getting the conductors that you want to pick up, okay? Make sure when you arrive, you can see there's some pre-work involved in here, determining what your service is, checking for any potential problems. The meter techs are the eyes and ears of the utility on a continuous basis. The line crews just go out for new construction or problems. If they have storms and that, then they send the line crews out when you've had some stuff go down. But as far as day-to-day, just on a regular, continuous basis, looking at the services and reporting anything back that you may need to send a line crew out for, that's the meter techs, all right? They're the eyes and ears on a continuous basis of the utility company, all right? So hopefully you've learned a lot from this on this ADIS site. It tested out fine. We got a good CT test. We got a good meter test. It fell within the parameters that were set up here on that kit. If we had set up different parameters, then it maybe would have tested differently. But at 100.000, that's gonna be a pass no matter what it is, no matter how tight you get it. So that was a great test on the meter. Also, what a testament to that site there. If it's over 30 years old and it's still tested that well, that's something. So the initial installation of the site, clearly they got some really good connections there, some really tight connections, and it hasn't loosened up over time, because we know that real small vibration in any of these electrical parts can loosen things up. So they did a great job at this site, tested fine CTs, tested fine on the meter, so you can consider this a good site, and say you can go on to the next one on this and just save all that data and then report it back and let them know this one's in good shape. So that is the last of for this site, the three videos that we've got for this site, and 3 seminars, webinars rather. So we're going to go ahead and the next one for May 11th, we're going to, if you guys send in and ask which of the ones you want, a 3, a 4, a 5, a 6, or a 9, we'll look at that, and if we don't get a tremendous amount of votes on that, we'll just pick one, okay? So let us know if you do have one in particular that you want to see. We'd be more than happy to put it on there and make it the next one. Otherwise, we're just going to pick one. I always leave that up to JP, and he'll pick the next one, and we'll go on to the next one. But this is the one that I'm at Mid-South Meter School right now. So next week I'll be live with you guys, and we'll do the next one. So as always, we appreciate you tuning in, and we appreciate your attention on this, and hopefully you're getting something good out of it. We're already getting a lot of good feedback on it, so it's really something to be able to out there and get live tests, and we're looking forward to show you even more of them. And it's a lot of editing for poor old JP. His workload didn't get any better once we got out of the field. It seemed to get even more after he did the filming. Now he's got to do a ton of editing, but he's the man for the job, so we're going to get you some good ones moving forward. And just thanks again for joining in. And you guys be careful out there, and God bless, okay?